Hi, my name is Aaron with iBoard Repair and iPhone Data Recovery, and today I'm working on an iPhone 12 mini. This one I've already taken out of the housing, so I just have the motherboard here. This one had no water damage, it had no drop damage, it just died randomly. So I've seen problems like this before, and I've already done my first initial diagnostic step, which is plugging in my probes for my DC power supply to the battery FPC here and observing what it does. And I can show you what it does here. As soon as I touch my probes to the connector, I get an immediate amp draw right there. So right there indicates a mainline short. That amp draw should not start until after I press the power button. Because it's starting before I press the power button, that indicates I have a shorted line. So I have many videos where I do this same thing, where I find a mainline short on the motherboard, and I have tons of videos about that. The main reason I wanted to make this one, however, was because it's on 12 mini, and I don't have very many iPhone 12 videos out yet, and I think it's good to get them out there and to show how these ones are worked on. So we'll dive right into it. We can start and see if we can verify that this is actually a VDD main short or if it's something else that's connected to it. And to do that, I just want to find a point on VDD main, and then I can check with my multimeter if it's measuring short or not. So to do that, I will open ZXW Tools, my board view software, and try to find a line. So ZXW, I think I already have it open. I started by clicking on the battery FPC here and trying to see where that goes, because it usually connects into VDD main somewhere. This board view isn't giving me any net names, so I don't know the names of these lines that I'm working on yet. It's still yet to be filled in. I'm sure that will be coming soon, but all the information is not available yet. But I did notice clicking on the other side of this capacitor here shows me what looks like main. I don't know for sure that this is main, but it looks like main to me. Usually the capacitors around the PMIC are main like that, so I'm fairly confident. So that shows me that this will be the easiest point to measure whether or not the line is short. So that would be right here. That would be right here at those little dots. So I'll turn on my multimeter and I'll just measure these dots here, and let's see if it's giving me a short. It's actually not. It's not showing short there. Interesting. So I expected that was going to give me a short, but this means that VDD main is likely not short, and it's likely some other component that's connected through VDD main, like the speaker lines can show short like that. But who knows? I really expected that one was going to be short, so now this will be maybe a little bit harder to figure out, but still shouldn't be too hard because it's giving me the amp draw before prompt to boot, which is indicating some short, and that short is going to give me heat. So when I inject voltage into the battery connector, that should at least give me some signal, but it might just go to, it might give me a false signal because I'm not injecting into the right line. So we'll have to see what happens. I'm curious to see if I inject directly into VDD main, if it's going to give me an amp draw, or if it only gives me the amp draw when I connect through the battery connector, which is, BAT VCC or something like that. I wouldn't expect any of the NAND power rails to be giving me that amp draw. That would usually only show up after I prompted it to boot. But this is a brand new motherboard, so a brand new model, I should say. So I don't really know how it responds to different signals right now, so kind of just have to experiment. So, oh yeah, that's what I was going to check if I get an amp draw when I touch main with voltage. And I do still. So, what can that be indicating to me? I'm not quite sure. I think to start off, I'll probably just try to pull this shield here and see if anything underneath there is heating up. Because it'd be easier if it was under there. Otherwise, I'm going to have to split this board and see what's going on the inside of it. So yeah, that will be the plan. So I'll pull this shield first. I think I'll get rid of some of this underfill in the way so it doesn't hold it down. Underfill is kind of weird. It doesn't want to come up. There are components next to NAND right here, so I have to be careful. That's probably fine. So I'd like to see if I can just lift this up. It looks like it will probably lift. So ground plane was a little bit disturbed, but that doesn't really matter. couple capacitors were knocked off, but again, that doesn't really matter either. So I don't see anything remarkable here, but I'm going to go ahead and inject into this line and just keep an eye out on this area and see if we can see anything heating up at all. I'm not sure that we will be able to, because again, we're injecting into a line that's not actually short, it's just connected to the line that's short, so it can very easily give us a false signal. Something could be heating up that's not the actual problem. So we do have to keep that in mind when we're looking at this. But I will go directly into main instead of the battery connector and see if that helps at all. Oh, interesting. It's heating up right here right away. So I don't know if that's on the other side or if it's just right there. Let's keep an eye out and look at that again. If we can see which one is actually heating up first. It's really hard to tell. So it looks like whatever is right here is what's heating up first. I don't even know if there's anything there. Let's see. So it looks like it's this area right here that's heating up. However, because we don't have very much information about this, I have no idea what these are. Just going over to this chip over here, which I also have no idea what it is. This chip looks like it is related to that is the LED connector, the screen. So this chip has something to do with the screen, and it looks like it's short something through there. So I'll most likely have to remove this shield too, because I think something's going to be going on under there. But first, let's see if we can measure one of these spots to see if it's showing short at these spots or not. It can also be that the heat is actually originating from the other side of this board, whatever is underneath here. That's also a possibility. That looks like a boost IC to me. The only reason I know that is because boost always has main in one corner and then the actual boost line in the other corner, and it does look like it's directly on the other side over here. So You know, this looks like boost too, so who knows? No, this one. Try it. It almost looks like I have two boost chips. No, because this one isn't main. So this is different. This one looks like boost to me. And then, so I think maybe I'll have a short right here at this capacitor. So let's check that. So right here, this capacitor, I suspect will show me short. Let's see if I'm right. Yes, short. There we go. So this is a boost short. There we go. I'm really glad to have found the shorted line. And the heat showing up right here in this area was actually a result from the chip on the other side of the board. Because when you have a boost short and you inject into main, what heats up is actually the boost IC and not the actual short itself. It's heating up the boost IC because that's where the voltage is going through to get to, or to get from main to boost, or the other way around. So, the problem is that there's not very much boost on this side. And I think it's going to be one of these caps probably that's actually short. Sorry, I forgot I left that up for a second. But I'll just measure where I measured again. So right by this other IC, I measured the little cap next to it. And that's giving me a short signal. But as I was saying, I don't think it's going to be short on this side. I think I'm going to have to split the board, and I think the short's going to be one of those caps that are right around boost up over there. But if I'm very, very lucky, there's 3 chances for it to be on this front side. One of them being right there. The other ones being these two guys, 1, 2. So I'll inject into one of those spots and see if one of the other capacitors heats up, but I really doubt it's going to. I'm almost surely going to have to split this board. As you can see, it's heating up in this spot again. There's a capacitor down there that's short. So I'm going to have to split this board because it's surely short on the inside. Splitting the iPhone 12 board is not fun. It's very difficult. You know what? The Mini might be easy. I'm not quite sure. I think I heard that the Mini was still using low melt solder around the perimeter. So we'll see that right now. So one moment while I grab my heating platform. Okay, got my platform here. I've never split a 12 mini before, so I'm not exactly sure what I expect. I'll get rid of this first, just so it doesn't hold the boards together. So yeah, we'll turn this on. I'm not quite sure how long it will take. I'm still going to put my normal 190 temperature, but I am not sure if that will be enough. I know on the 12 Pro I had to go all the way up to 220, which is pretty high for when you're splitting a sandwich. It can start causing other problems on the board, but it turned out okay. But this one I'm going to start at 190. I'm going to see if that's enough for me. And we'll wait 3 or 4 minutes, and then I'll try to split this board. So I'll put a timer on my phone for 4 minutes, and I'll probably come back in 3 minutes and see if it's ready. So I'll wait 3 minutes, and then I'll be right back with you guys. Okay, it's been 3.5 minutes, so let's see if this is ready to pull. I don't know if it's going to be ready or not. I don't even know the best entrance point for this, so I'm just going to choose any one. You know, it doesn't seem like it wants to come up yet, but yeah, now it's hit 4 minutes. It may want a higher temperature after all, because this isn't ready to budge yet. Oh, there it goes. It's almost getting there. It wasn't too bad. Looks like I may have some gray pads, but I don't think anything ripped or anything. It probably could have used a little bit more heat or a little bit more time, but it's, like I said, not too bad. Nothing's broken. My desk is a little too messy. Let me just clean this up. Okay. So yeah, a lot of these pads are gray, and that's usually a result of not quite enough heat before I pulled it. So they didn't rip or anything, which is good, but like I said, they could have used a little bit more heat or a little bit more time under that heat. So right here is my VDD boost. I'm just assuming it's VDD boost, but I'm almost positive it is. And it's going to be one of these caps around here is bad. So let's double check which ones are around there. Two to the left and three underneath it. So these two or these three. Guaranteed one of those is going to be bad. Not guaranteed, but I highly, highly suspect. So I'll just clean this motherboard real quick just because I like to work with clean boards. I've heard reports that if you try to boot with just the top board on the 12 series, that you'll get some sort of temperature sensor warning. I've seen myself, no, never mind. But yeah, I guess I'll check that myself in this case. This is a 12 mini, so it may be different than some of the other models. So let's just double check, or let's just check which one of these caps is going to be the culprit. And I'll do that by just choosing a random one to inject voltage into. I have to keep in mind that the cap I'm injecting into may also be the culprit. So if it heats up abnormally fast, then I should double check on a different cap. Yeah, so the one I'm injecting into is almost surely the culprit because that was just so fast. So I'll check with a different cap to see if that one's still heating up. So we'll check with this cap instead. I'll just use this ground. And yeah, the thing heats right up. So there's my problem. So once that's removed, this should boot right up. Hello. So let's check the line now. Should be clear. Yeah, clear. So I will go ahead and I'll need a battery screen and a charge port to test this. So I'm actually using the housing that this motherboard came in for a different data recovery job because I knew that all the parts were good on that because there was no water damage or anything. So once I'm done using that, I'll come back and I'll test those parts with this board. I'll just pause the video until then. So I'll be back in a moment. Okay, I have my charge port, well actually my housing, my battery, and my screen. So I believe the only thing needed for, like, the only flex cable needed for data recovery is the charge port. In older models, or the iPhone 11 I should say, you would need the power button, but on the iPhone 12, at least the 12 Pro I've already tested, you don't need the power button. I don't know if that's the same case with the 12 mini. It might be different, I really don't know. But on the 12, you just needed the charge port. So let's see if this thing wants to boot with just the top board. I actually don't know. I only have the reports that it would get a temperature sensor warning. So let's see if that's going to be the case with the Mini or not. So let's see if it wants to boot when I prompt it to. You know, I don't think I plugged in the power button at all. I'll just prompt it with a charge port. No passcode. It says there's no passcode. I have an Apple logo, so definitely short's taken care of now. I guess we'll see if this thing wants to stay on or if it's going to give me a temperature sensor without the bottom board attached. I do see the phone fully booted. No password as indicated. I'll show you that it's actually plugged in. You might be able to hear it, but I'll show you that it's plugged in by connecting it to the computer. Probably asking for trust. So it's not asking for trust, and it's also not recognized by the computer. So what's going on? Oh, there it goes. Trust. So I'll show you. As you can see, I'm in. It's reading the battery data fine. I'm not getting a temperature sensor warning yet, so I do think it's just working now. So that should be it. So I'm going to go ahead and run the data run the extraction now, and I'll be able to pull a backup from this phone, and the customer is going to be very happy. The only thing I have to worry about is if I'm going to get a 3-minute reboot, which I don't think I will, and if I was going to get a temperature sensor warning, I think I already would have gotten it. So I think it's working. I'll just go ahead and pause the video for 3 minutes so I can just, wrap it up with more finality, and I'll let you know how that goes. So I'll pause the video for a couple minutes. Okay, it's been about 3 minutes. I didn't time it or anything, but it seems like it's been long enough. The phone's still on. The extraction is going to be fine. So power button, officially declaring it's not needed for data recovery anymore. It doesn't cause the 3-minute reboot like on the 11 series. Just the charge port's needed. At least on the 12 mini. I don't know if that's the case for every 12. I know I've tested on either the 12 Pro or 12 Pro Max as well, and it also wasn't needed there. So it's pretty likely that power button's not needed for any 12 series. Anyways, this one was not too bad. It had a mainline type short that I was able to see when I connected my DC power supply to the battery connector when I first started. I determined that VDD main was not the culprit, and it was actually VDD boost. And we were able to find that boost short after we split the board. And it looks like we'll be able to take data with just top board only. I'm not seeing any temperature sensor problems or anything like that. So that's it. Hope you enjoyed the video. Hope you stop by again. Leave a like if you don't mind. Thanks. Bye.